Welcome back. Today we'll finish section 2-2, and for example 4, we're going to write the equation of a parabola given 3 points. If I sketch the 3 points, negative 232, 1, 5, and 317, we know that this parabola is going to open up, but we don't know exactly where this vertex will be. Okay, so for this one, we're going to have to write a system of equations. And the equations are going to be based off of the standard form of a parabola. So for the first point, negative 232, I'm going to plug in or substitute 32 in for y and negative 2 for x, wherever I see it in the equation. This simplifies to equal 32 equals 4a minus 2b plus c. Now let's plug in the second point, 1, 5. Again, 5 will be plugged in for y, and whenever I plug in 1 for x, I'll just get a plus b plus c. Now for the last one, 317, the equation will equal 17 times 3 squared plus b times 3 plus c. So I can rewrite it as 17 equals 9a plus 3b plus c. So here we have 3 equations, and we have 3 variables. So we're going to have to use some algebra to solve this problem. Now let's solve this system of equations with 3 variables. When I look at the coefficients and I want to eliminate a variable, it's really important that we find one that is very similar. And if you can see, all the equations have a plus c, right? So if I actually subtracted one of the equations from another, I could cancel out the c. So that's what we're going to do. We're going to write each equation. So here's 32 equals 4a minus 2b plus c. And then I'm going to use the other one, 17 equals 9a plus 3b plus c. And what I'm going to do is take the one in the middle, multiply it by negative 1, and I'm going to essentially subtract it from each of the other equations. So negative 5 equals negative a minus b minus c. And I'm going to do that to the other equation as well. And what we're going to do, let me just make a line here, is we're going to subtract these and get new equations. So 32 minus 5 is 27. 4a minus a is 3a, and negative 2b minus b is negative 3b. And you can see that the c's are going to cancel out. What I can do with this equation is divide everything by 3, because you can see that it's all divisible by 3, and get the equation 9 equals a minus b. Now I've already gotten my equations down to 2 variables. So we went from 3 variables to 2 variables. And when I have an equation with 2 variables, I want another equation with those same 2 variables. So when we put these together over here, and let me use a different color. So 17 minus 5, that's 12. 9a minus a will be 8a. 3b minus b is plus 2b. And you can see the c's cancel out again. Now everything in here is even. So I'm going to divide everything by 2, just to make it a little bit easier. So we'll get 6 equals 4a plus b. So what you can do, you can see right here, well, if I have these 2 equations, I could substitute, right, and solve, or I could use elimination again. And I actually want to use elimination because I have a plus b and a minus b. So I'm going to write this equation over here. The 6 equals 4a plus b, and I'm going to combine it with the other one. So this is going to be 6 equals 4a plus b, and we're going to add those. So when we add them, we get 15 equals 5a. Now we have one variable. So we went from 3 to 2 down to 1. And if we divide both sides by 5, almost write the answer there, a will equal 3. All right, so now we just have to work backwards to get the other variables. So I'm going to use this one. You could use this equation or this equation to get back to b, right? So 6 equals 4 times 3 plus b. So 6 equals negative, that's going to be plus 12. Plus b, and then when I subtract 12, we'll get negative 6 equals b. And then for the last one, well, I'm going to go back to my 5 equals a plus b plus c. Because we know what a equals, we know what b equals. So 5 equals 3 minus 6 plus c. This will be negative 3. So c equals 8. Now, remember, we were trying to find the variables, those coefficients for the equation. Y equals ax squared plus bx plus c for the parabola. So we know that a equals 3. We know that b equals negative 6. And c equals 8. So our parabola would be 3x squared minus 6x plus 8. Now for example 5, we're going to use a quadratic regression, meaning we're going to derive the equation of a parabola. And remember, we want the equation in standard form given the path of the ball. So here we have Esteban. He has the discus throw. And his coach probably used some videography, okay, some filming, and was able to record the horizontal distance and the height of his discus throws. So we can see that at one, right here, this would be 1 meter from Esteban, right? This distance is 1 meter. This discus had a height of 1.75 meters. And then if we go along, we could see when the discus was 4 meters from Esteban, it had a height of 4.28. So using all these data points, we can approximate a parabola, right? It's not going to be perfect, right? This shape, you can see that there's this discus is a little bit out here and here, but what we're going to do is use a regression to find the parabola that best fits this data. And we want to figure out and predict the height of the discus when it is 15 meters from Esteban. So let's plug this into our graphing calculators or into Desmos. So when I plug this into Desmos, and I'm going to actually stretch this a little bit so we can kind of see this parabola, okay? So here's the data points. And you can see that the parabola is going above, right? And then it starts to drop down. So it hasn't even with all of this recording, the coach didn't record the highest value. And you can kind of see over here that the vertex is probably really close to 19 or 20, right? So it's up here. So we have the data points, and with Desmos, it gives you the equation over here. Y is approximately, right? ax squared plus bx plus c. It gives you an r squared value. The r squared, when it's close to +1 or close to -1, it's going to be really close. That's going to be a good graph, a good representation of the data. If the r squared is close to 0, then we can't really find a good model, okay? Or the model that's given doesn't fit the data. But we have the parameters here, and you can kind of see it in a small type, but a is negative 0.0270833. You could see b and c, and those are the coefficients for the equation. So let me go back here, and with the technology, I was able to see that a was equal to negative, and I'm going to round to the thousandths, 0.027. B was equal to 1.058, and C was equal, and I should say it's approximately because I'm rounding here, 672. So an equation for this parabola would be negative, right? Because it's opening down, 0.027 x squared, because that's my A, plus 1.058 times x, because that's our B, and then our constant is 0.672. That's the equation. Now, if we're going to figure out the height, remember the height was going to be the y. So if I plug in 15 for x, I'll get the height, or the approximate height. So this is going to be y equals negative 0.02715 squared plus 1.058 times 15 plus 0.72. All right, let's simplify. So this equals negative 6.075, and this was 15.87 and 0.672. So this approximate height for Esteban's discus throw would be 10.467 meters. And let's just confirm that with the graph. So when we look at the graph, remember we're saying what is the height at 15? Well, yeah, you can see 15 it'll be a little bit more than 10. So about 10.5. Well, thanks for spending time with me. I hope this lesson was helpful.